Hello and welcome to the presentation of my research. My name is Ashleigh Francis and I am a student that has just completed a Bachelor of Science in Geography at Bournemouth University. My research investigates orbital observations of Ultraviolet Aerosol Index as a proxy for harmful particulates at ground level. I look forward to explaining my project throughout this presentation and I hope you enjoy. Poor air quality has been recognised as the largest environmental risk to public health in the UK, with the ability to cause severe health conditions such as cardiovascular and respiratory diseases. The diagram on the left shows a collective of non-communicable diseases that are severely worsened by air pollution, and the pie chart shows the percentages of deaths caused by ambient air pollution that were attributable to individual diseases in 2012. This frames the context of my research and why air pollution is an important problem to focus on in the UK. One of the most aggressive constituents of this air pollution is particulate matter. My investigation focused on both PM2.5 and PM10. PM2.5 refers to a particle of pollution with an aerodynamic diameter of 2.5 micrometers or less, and PM10 refers to that with a diameter of 10 micrometers or less. The diagram on the right shows the relative sizes of each of these compared with a human hair and a grain of sand for some perspective. The very small sizes of these particles make them more likely to be inhaled in the respiratory system, causing damage to human health. There is a significant urgency to monitor particulate matter, which has in the past been done mostly through direct techniques using manual detectors. However, there are complexities associated with this type of monitoring that could potentially be avoided using indirect monitoring of particulate matter through methods of remote sensing. Research developments throughout the 21st century have revealed the potential for remotely sensed data, such as Ultraviolet Aerosol Index, to be used as proxies for ground-level particulate matter. The use of such proxies could help to predict long-term concentration for use in health and medical studies, taking into account both the spatial and temporal distribution in terms of exposure. Sentinel-5P is a satellite designed to collect remotely sensed atmospheric data. The top right diagram shows an artist's impression of the satellite. Sentinel-5P is part of the Sentinel suite of Earth observation satellite missions launched by the European Space Agency on behalf of the EU's Copernicus programme, which funds the mission. The mission is one of many within the Copernicus Sentinel programme, shown by the diagram on the left, and is a facilitating platform for the tropospheric monitoring instrument developed by the ESA, shown as an artist's impression in the bottom right photograph. The aim of my research was to evaluate the potential of remotely sensed ultraviolet aerosol index as a proxy for particulate matter concentration at ground level in the non-industrial conurbation of South East Dorset that includes Bournemouth and Poole. My research questions were: is there a relationship between remotely sensed UVAI data and ground level observations of particulate matter, and could this relationship be used as a proxy for ground-based particulate matter concentrations? The chosen study site for this investigation includes areas of both Bournemouth and Poole within South East Dorset. This area was chosen to focus on investigating particulate matter emitted exclusively from exhaust emissions, as the region does not engage in industrial activity. The map shown on the slide shows this area in addition to all the sample points that were chosen to observe particulate matter at. These were chosen using predetermined traffic count data from the Department for Transport, which allowed the creation of 4 categories of traffic intensity listed in the legend of the map. I have also included a typical pixel size for tropomi to show how UVAI measurements would be obtained here. Upon arrival at each location, a practical place to sample was identified, and the instrument, a Casella CEL 712 Microdust Pro, shown on the right hand side, was set to sample for 5 minutes for each of PM2.5 and PM10. I have labelled each piece for ease of presentation purposes. So A shows the air sampler itself, B shows a PM2.5 filter, C is the PM10 filter contained in its bracket ready to use, and D is the sampling pump that sucks air in at a rate of 3.5 litres per minute to allow for sampling. E is the probe that allows for calibration of this instrument to avoid contamination between taken samples. This yielded mean measurements over each sample period and was repeated over 4 days. The orange table includes the pilot study on the 21st of February, but this was not included in the results that I'm going to show you today. Ultraviolet Aerosol Index data from Tropomi were obtained via the Sentinel 5P pre-operations data hub. For each date that the data were collected, UVAI of 2 wavelengths were collected for 340 to 380 nanometers and 354 to 388 nanometers of the electromagnetic spectrum. This was to remain consistent with previous missions. The equation shown on the slide is how UVAI is calculated using the data sensed by Tropomi before it is made available as data on the hub. These values were then interpolated at each of the sample sites using inverse distance weighting in GIS software for optimal analysis. So now on to results. This series of scatter plots shows UVAI residual values which were all negative against both types of PM observations, with trend lines inserted for all dates. This shows a very weak positive relationship that as particulate matter concentration increases, as do UVAI residual values. However, it must be taken into consideration that other factors such as meteorology and geographical location of sample sites could have also influenced this result. In conclusion, all UVAI values remain negative across all dates of data collection, which suggests the presence of weakly or non-absorbing aerosols in the atmosphere. My results concluded a weak positive relationship between UVAI residual values and PM concentration, which appears stronger in the relationship between UVAI values for both wavelengths plotted against PM2.5 than PM10. This relationship could therefore have the potential to be used as a proxy for ground-based concentration of particulate matter, but only with additional investigation to provide more robust results that could warrant statistical analysis, affording the opportunity to conclude a definitive correlation. Thank you for listening to my research, and I hope you enjoyed. Please get in touch with me via LinkedIn if you have any questions at all.